Okay, we are moving into Chapter 2 of our statistics class notes. Here we are on page 8. Chapter 2 is generally entitled Picturing Variation with Graphs. And the main topics of this entire chapter are to be able to visualize, so visualizing variation in numerical and categorical data, and summarizing important features in numerical and categorical distributions. So in section 2.1, we're going to be visualizing variation in numerical data. We're going to start with numerical data first. Okay, and then we're going to explore distributions of numerical data, and then we're going to learn about dot plots, frequency or relative frequency histograms, and stem plots. What is the distribution of a sample? So recall, any collection of data will have variation within the data. Remember, variation means differences. An important tool for organizing and evaluating the variation in the data is called the distribution of the sample. In other words, we're going to take our sample and we're going to plot it. We're going to take a sample, which is a subset of a population. We're going to get our information and we're going to try to plot it. There are three main components of a numerical distribution. So what does it look like, right? So shape, what does it look like visually? What does it look like visually? And we'll talk much more about these things as we go along. But the three main things are shape, center, and spread. So shape is what does it look like visually? The center is what is its typical value? What's the center of the distribution? In other words, typically what would we expect? And what does the spread look like? And when I say spread, I'm talking about the horizontal spread when I plot it, okay? How many different values are there? Are there a lot of different values that spread way out, or is everything kind of clumped around a few values? Okay, so that's spread. So for example, here's some raw data on the number of games played by a sample of professional female soccer players during some given season, sorted in ascending order. I actually got this in StatCrunch, which you haven't learned about StatCrunch yet, but we're going to start that today. And this is a data set. StatCrunch has a lot of data sets you can pull from. So these are a number of games played by a sample of professional female soccer players during a given season. So one of the first things you do when you get data is you first sort it. You put it in ascending order, start with the low numbers, get higher and higher and higher, and move up to the highest number, or vice versa. But we sort it first. I'm not going to deal with that. We don't need to sort when we use StatCrunch. So I'm giving you data when I do examples sorted. What I want to make a note of is that the distributions record all observed data values. So this is the distribution, and it's recording all the observed data values. But looking at that, just looking at the raw numbers, even though I have it sorted, it's getting kind of hard to see if there's any patterns in that raw data. And that's what we want to be able to see. So one of the first things you can do is construct what's called a frequency table, which is the distribution of data can be organized this way. This is a table where I list all the different outcomes that happened. There were some female soccer players who only played one game. There were 3 of them. There was one female soccer player that played 2 games. There was another one that played 5. There was another one that played 6, etc. There was 2 that played 10, 4 that played 11, etc. So what I did is I just filled out this frequency table that way. 3 soccer players played 1 game. Looking at 15, we have 2 played 15, etc., etc. Okay, so that's called constructing a frequency table.